All right, let's take a look at this very interesting question. We have tan square theta equals to sec theta plus 1. And we're supposed to solve. And when you're told to solve, you are supposed to find the value for theta in this particular equation. Now, I'm sure we all recollect our basic identity. And we know that our basic identity stated that our sec square theta was equals to 1 plus tan square theta. So this obviously is one of the identity we actually will be using to solve this particular question. So what do we have to do here? Of course, don't forget, it is actually sec square theta that was equal to 1 plus tan square theta. So we will not be changing the sec square theta, rather we'll be changing for tan square theta. So what we will have here is that our tan square theta from this identity will be equals to sec square theta minus 1. So we'll be fixing this into our equation to get, don't forget I told you the main reason why we're doing this is because for you to be able to solve questions of this sort, you want to have the same trigonometry function. So we have tan theta here, we have sec theta here. You want to find a way to bring every one of them to just one particular trigonometry function. So we have from this our identity, we'll be able to change this tan square theta to sec square theta minus 1 equals to sec theta plus 1. It's always good practice to make use of your brackets so that you don't make mistakes. So I can go on to open my bracket here. And then what I have to do next is to collect the like terms. So I want to bring the trigonometry functions to the left-hand side and the non-trigonometry functions, that's the constant values, to the right-hand side. And actually, I'll bring in everything to the left-hand side because one of the things I'm seeing now is that this is taking a quadratic equation form. So I would love to have every one of them in one side. So if I have sec square theta minus sec theta minus 1 equals to 0, this obviously, minus 1 can condense to minus 2. So this is the equation I'll be having. And if you can look carefully, you would see that this looks very much like a quadratic equation. Actually, it's a quadratic equation. So, but for the sake of those that may not be able to see clearly at this point, let's decide to represent our sec theta with x. So obviously, our sec square theta will be x squared, and then this will be minus x minus 2 equals to 0. So I'm sure you can see now that this is an exact quadratic equation. So, and using factorization, looking for two factors, I'm sure you agree with me that those factors will be minus 2x plus plus 1x. So solving this will have x into bracket x minus 2 plus 1 into bracket x minus 2 equals to 0. So what we have here is x plus 1 and x minus 2 equals to 0. That means our x is equals to minus 1 or 2. Now don't forget that our x was represented with sec theta. So I can go on to write sec theta equals to minus 1 or sec theta equals to 2. Now this brings me to the application of the inverse of this reciprocal trigonometries. Sec theta, cosec theta, and cot theta are what we call reciprocals of trigonometry functions. So how do you go on to find? Of course, for us to find this, the same method, this is where at this point we have to apply angle of any magnitude. And what you're supposed to do initially was to say theta equals to arc sec minus 1. Or for this particular case, our theta is equals to arc sec 2. Now, what you have to do here because you do not have, in almost every cases, the sec theta on your calculator. So this is not, you can't press this on a calculator because you don't have sec theta. But what you can do is to use your understanding of secant and its reciprocal. Secant is actually 1 over cos theta. So that means for you to find the arc secant, we can decide to find the arc cos of 1 over minus 1. In this case, for us to find the arc secant here, we'll be finding the arc cos of 1 over 2. So that's the way you solve these questions when you come to a point where you're having arc sec or arc cosec or arc cot. You will just go on to use the reciprocal, but instead of using the same value here, you're using 1 over the particular answer. So this will be obviously arc cos. Now I told you already, sorry, I'm not supposed to put the minus sign here, because when you are trying to find angle of any magnitude, you're not supposed to have the minus there. So this will be arc cos of 1, or theta being arc cos of 0.5. So you can easily press this on your calculator at this stage. So the arc cos of 1 is actually 0. So theta here is equals to 0 degree, or theta here is equals to 60 degree. So this is not our final answer, don't forget. We then need to go on to examine using our quadrant, where is, of course, when you're dealing with your quadrant, all students take calculus. I told you in a previous video that wherever you have cos, you also have the secant here. So cos is positive here and cos is positive in the first and fourth quadrant. The same thing goes for secant. So secant is also positive in the first and fourth quadrant. So in this particular case, you have secant being negative because this is minus 1. So that means you'll be dealing with the second and third quadrant. So our quadrant of interest is the second quadrant and the third quadrant. That's for this particular side of things. And for this side of things, we have secant being positive because this is plus 2. So our quadrant of interest will be first and fourth quadrant. So you need to go on to then establish the final result from using this quadrant. So from this quadrant, second and third quadrant, the rules that operate there is 180 minus theta. Theta here being 0, that will be 180 minus 0. That will be 180 degree. And for the third quadrant, we have theta plus 180. 180, 0 plus 180 is also 180 degree. Now for the other one we have here, theta is 60 degree. I told you when you have the first quadrant, you replicate the same thing there. And for the fourth quadrant, we have 360 minus theta as the rule that operates there. That will be 360 minus 60 degree. That will be 300 degree. So taking a look at this particular question now, we can conclude that the value of our theta will be 60 degree, 180 degree, and 300 degree. So that's going to be our answer here. Our theta is 60, 180, and 300 degree. So this is how you solve for questions like this. It's very simple, very straightforward. You just need to follow the process and you will never go wrong. Thank you guys.